Hey guys, Vladimir here. In my last video, I demonstrated a simple example showing why sketch constraints are so powerful. And today I want to continue that lesson as we look to design this icosahedron. At first glance, it looks to be a very complex and intimidating design to tackle, but I'm going to show you how we can design most of it with just one sketch tool and one constraint. This model is part of a bigger project I'm working on, which involves 3D printing and laser cutting, but I'll reveal the details in a future video. I'm actually very excited about this project and looking forward to sharing the details with you. But for today's video, I want to keep the focus on how I approach this design and how taking advantage of just one sketch constraint really simplified my design approach. Oh, and before I forget, I created a Fusion 360 sketch constraint cheat sheet that you can download and print out or save to your desktop. I highly recommend doing so, as I list all the sketch constraints with a description of how each one works, along with a graphic demonstrating how to use each one. You'll find it incredibly valuable as you begin incorporating sketch constraints into your designs. The link to get the cheat sheet is below in the video description. Okay, back to our icosahedron. As I was thinking about how to approach this design, I came up with a few ideas, and then I said, let me see what other approaches that others have used. And since this is YouTube, I did a quick search to see the different design strategies. A lot of them involve very complex strategies with multiple sketches with very specific dimensions and angles, construction lines and planes and formulas and patterns. My mind always wants to go to the simplest solution, and I knew there had to be a much simpler approach. That's when I came across this genius approach by First New York City's channel, who used 3D sketching to create the entire shape, and I thought, this is the way. And also, as a former FIRST robotics coach myself, I want to give a shout out to my robotics coaches out there, especially First New York City, for showing this technique. I'm going to basically be using the same approach, but will modify it slightly to take advantage of some of the circular pattern tools available to us. Okay, let's dive in. So an icosahedron is made up of 20 equilateral triangles. You can see here clearly if I select one of these faces that it's a triangle, and if I select any one of these edges, they're all going to be the same length. As we can see here, they're all 25 millimeters. We're going to start with that simple definition, and I'm going to build on that to explain how just that one simple fact allows me to build this entire shape and use a simplified approach to designing this shape here. So let me go into, I'm going to create a new sketch here, and just to show what I mean here, I'm going to create a sketch on my XY plane. And I don't want to jump into 3D sketch yet, so let me go to a top view. Okay, what I'm going to do is just grab my line tool and just create a simple triangle. So 1, 2, 3 sides here. Okay, so now that I have that triangle, and if I want this to be an equilateral triangle, well, it's easy to do that if I use my equal constraint. I simply have to select that equal constraint, choose one side, make it equal to the other one, and then choose that third side and make it equal to any one of the two sides. Now, if I select any one of these sides here, you can see that they're all the same distance, all the same dimension. Okay. Yeah, very basic so far. But not only that, if I grab my dimension tool, by definition of an equilateral triangle, I will see that all of these angles are also going to be the same. And I didn't have to put those in, right? It's just sort of built into how this works. These are all 60 degrees. And it doesn't matter how I create this, which is the neat thing here. I can start it any way. I can create the craziest lopsided triangle, but simply use my constraints, and boom, I've got an equilateral triangle. And if I make this, put a parallel constraint there, make it 50 millimeters, for example, do the same thing to this one. It doesn't matter how I start the design, they are now the exact same thing. Okay, I want to just kind of start with that to kind of build where we're going with this, because the beauty here is that these angles take care of themselves. So when I go to create something like this, all these internal angles are also going to take care of themselves, because all I have to worry about is just the length of these sides. And that's going to be very easy using my equal constraint. So I'm going to show how I'm going to build most of this shape here simply by using my line tool and my equal constraint. All right, so let me close this and we're going to start a new design here. And I'm going to begin with a sketch on my XY plane. And I'll grab my polygon tool to create a polygon, specifically a pentagon. So we're going to go straight down here. I'm going to hit tab, make this 5 sides. There's my polygon. I can rotate this. It's not constrained at all. So let me just put a one constraint here on the bottom, a horizontal constraint. And let's go ahead and add a dimension here. I'll just make this 50 millimeters. And again, by definition, dimensioning that one side makes all these other sides the same length, and it's fully constrained. Okay, and this is the only sketch I need. Well, kind of is and kind of isn't, because what I'm going to do is I'm going to jump into 3D Sketch. I'm going to click on my sketch palette here. You'll see the option for 3D Sketch. I'm going to go ahead and click on that. And that's now going to allow me to continue my sketch while sketching on any plane without having to stop the sketch and then restart it in a different plane. And it's not going to limit me to only sketching on that one plane. So here, let me demonstrate. I'm just going to go ahead and let's grab my line tool again. I'm going to start right at the origin there. The way this works is I'll click to select that origin point, and you can see my 3 planes here, and I can basically tell it which plane I want to sketch in. So I'm going to choose this ZX, or that blue-red plane, and now I can go straight up, or I can go straight up and add an angle here. So what I'm going to do is I'm just going to go straight up, referencing that axis, that blue axis line, and then I'm going to come down and snap to this corner right here. And the beauty with 3D Sketch, or a nice tip to keep in mind, if you have a framework already in place, like a sketch or a model, 3D shape that you can reference edges, it makes it so much easier, because then you don't really have to worry about selecting the planes. You just kind of select one point and then the next point. And it goes along very quickly. So you can see there that now I have this prism shape. And here's the beauty now. So I have this one side here that's dimension. And what I'm going to do is I'm going to then grab my equal constraint and select another side here, one of these angled lines I made, and make it equal to that first dimension that I gave. And let me undo and redo that there, because that happened kind of quick. Notice how all these other lines kind of moved into place when I did that. So I'm going to redo, and it took care of everything. I'm gonna do it one more time. I think this pretty much takes care of it, but I'm gonna do it with this other line. And I know that they are all constrained or all equal when I get an error message that's gonna tell me that it's over constrained. So here it is, sketch geometry is over constrained. Now if I hit escape, I can select each one of these lines, and I can see that's gonna tell me that those are all 50 millimeters. So I know that I'm all set here. These, not only are these all the same distances, these lines are all the same lengths, but all these angles are also going to be the same. It takes care of those angles by definition, because this pentagon here is all, each side is 50 millimeters, they're all the same. And if this distance isn't changing, then these all have to be the same length, and in turn these angles all have to be the same. So it works itself out. You just have to worry about that equal constraint and making them equal. Now I'm going to select this line here. I'm just going to make that a construction line. I don't need that to be solid. Okay, we've gotten the top part taken care of, so let's continue designing the rest. I'm going to go to my front view. I'm going to grab my line tool again, and this time I'm going to reference this front edge here. Choose the plane I want to go in. So I don't have an existing point to snap to, so I need to tell it I want to be on this ZX plane here, that blue-red plane. And now it's going to allow me to sketch on that plane. So I'm going to go straight down or at an angle there and then come back up. And I'm not going to fuss about getting this to match this midpoint or these angles, because now all I have to do is grab my equal constraint, select this line, make it equal to this line here, and do the same thing with this other line here. And now I can verify that these are all 50 millimeters. Now, I'm choosing this line here just to keep it neat. The truth is I can constrain any one of these lines. I can choose this line or this one and constrain it to any other one, because they're all the same. But I'd rather just have all my constraints reference the same edge here, and that I'll just keep it neater. Okay, now that I have this triangle going straight down, what I'm going to do is take advantage of my circular pattern tool. I'll go to create, down to circular pattern. I'm going to select these two edges there, choose a center point here, and I'll click on the origin or my center origin there. No, I want 5 of these because it's a pentagon, it's got 5 sides, and then I'll click OK, and there you have it. I've got my 5 sides there. Now you can kind of see an issue there. Let me go back and reference my original icosahedron there, and you can see that if I maybe a little bit difficult to see here, but anyway, these edges don't come straight down, they kind of come angled, so I can see that that's wrong. These aren't supposed to come straight down, but we're going to take care of that just by, you know, one constraint again, our equal constraint. But first I need to create another line. So I'm going to create a line between this point and this adjacent point here. And now that I have that line, watch actually, so this actually tripped me up the first few times. I kept forgetting to constrain this line. Notice that that line is not the right dimension. It's 39.6 instead of 50. And the reason for that is because these angles aren't right. This is supposed to flare out. And if you continue modeling without taking care of that, it's just not going to work. So what I'm going to do is again grab my equal constraint, make that line again equal to this line here, and you see how that took care of the angles. It didn't just take care of that line. In order for it to make that line equal, it had to change the angle of these triangles. So that's another one I want to redo and undo so you can clearly see it. So this is, I'm going to go straight up down. You can see the view from there, and if I redo, you can see how they flare out. Do it one more time from this angle here. Redo before I set that constraint, or undo and then redo, and you see they flare out. So now that's 50 millimeters. Okay, and that takes care of those angles. So what I'm going to do is grab my circular pattern tool again, choose just that one line, and I'm gonna create a pattern of that. Choose my center point, give it 5, click OK, and now I've got this center portion done. And let's just flip it over and quickly do the bottom portion. So again, we're going to grab our line tool, choose any one of these corners here, choose the plane I want to sketch in. It just needs to go in you know, a Z direction here, so I'll choose ZX, and I'm just going to go up at an angle, not worrying about it, and coming down and snapping to one of the adjacent edges, or adjacent points, I should say. And I'm going to do the same thing. So following that same principle I did with the top section, I'm going to just snap to that center point and then come down to any one of these bottom points. You know, I can see that this is completely off. You know, you can tell that that's way off. So I'm going to grab my equal constraint, choose one of these angled lines, make that constraint to my original line there, and it'll start moving it in place. It's going to take more than one for this one to actually get it right, so let's keep going. And I'm going to apply that same approach. I'm just going to keep going, and you'll kind of see when it kind of takes care of itself. But you'll also notice that you'll get an over constraint if you try to do one more. So right there I can tell that looks to be good, but I'm going to try one more just to be safe and sure. And so you can see the wheels are spinning right now. It's trying to do that calculation, and I can tell just how long it's taking, that it's going to tell me that it is over constraint. So give that a couple seconds, and there's the error, sketch geometry is over constraint. And then of course you can always verify by just selecting on these edges and verifying that they are all 50 millimeters. So yeah, there it is, and this is our completed shape. You know, only using basically one sketch tool, which is our line tool. You know, we made this complete icosahedron just using the line tool and applying one equal constraint. A little bit of geometry and everything else just falls into place. So yeah, how powerful is that? Now, of course, this is just a sort of a framework. These are only profiles. We want to get to, you know, this point or somewhere in between here. You know, we want a solid body basically. So I'll show you a quick way to do that. I'm going to finish the sketch here. And what we're going to do is we're going to jump into our surface environment. Notice you have your solid and your surface and your mesh. We're going to go into surface. we're going to grab our patch tool. So we'll go to create down to patch, and a patch allows you to create basically a patch out of a profile. So what we'll do is we're going to select each of these profiles. You want to be careful you don't click on an edge. You want to actually click on the center of the profile, and see if I hover over an edge, it highlights it blue. So try not to do that. And notice how it keeps count. It's telling me I've got 5 so far, and we're just going to do that for each one. I know that there are 10 in this center section, so you want to make sure to select them all, otherwise this is not going to work. Okay, and then we can, and you can also see if you missed any of the ones here, because they're they're going to be not highlighted. So let me go ahead and just continue selecting these. I missed a few on the bottom here. So yeah, the nice thing is that if you've already selected it, it'll actually it'll deselect it, so the count will go down. And then once you select them all, you'll go ahead and see that it'll say 20. So just make sure you get them all selected and that it says 20 profiles selected, and then click OK. And now you'll have a solid, well, it's not actually solid yet. What we really do have is 20 different bodies. And if I click on any one of these here and untoggle the visibility, you can see that it's just a surface got removed and I can see through the model. So yeah, it's kind of like making this out of like sheets of paper. Not really, because paper actually has thickness, but these don't have any thickness, these surfaces. But it kind of gets the idea apart. You're just kind of building this out of paper, and there's nothing solid here. Okay, so now to make it solid, all we have to do is go to modify and go to stitch. We are basically going to stitch everything together. And it's easier to make that selection here from our browser than it is to try to select each one of these again. So we can simply go ahead and choose the first one, click shift, and then click on the last one here so that they're all highlighted, and then I'll click OK. And now we have a solid body there. If I go back to our solid tab here, we can verify that it is solid. If you go to inspect, do a section analysis, choose any one of these faces and drag in, see that that's completely solid. And we can, do anything we can do with a solid body. For example, if I go to modify and do shell, let's go ahead and select the body here in our browser, and I'll do, let's say, a 3mm shell there. Click OK, and then I do a section analysis, and then go inwards, and you can see that that's shelled on the inside, 3mm. So, okay, that's basically what I wanted to show here. The power of using constraints, where it allows you to just create this really complex shape by taking advantage of a little geometry knowledge and your sketch constraints. So in the next video, I'll go into, I don't know if it'll be next, but it'll be shortly, maybe a future video, I'll say. I'm gonna go ahead and talk about how I got that model here and to be this shape here, which basically, involved bringing in, I took an SVG file and I imported it using my insert SVG option here. The pattern was actually designed in Illustrator, and then I brought that in, created the extrusion, and then did a few circular patterns here to create this shape. So I really love this approach to these designs. I think they make such beautiful models. You can make all sorts of lamps and lampshades and just these really neat geometric shapes. And so this is going to end up being laser cut, but I also want to 3D print some of these. I don't know if you can see there's like an actual bulb on the inside here. If I deselect this body, you'll see that it's white, so I have to select it so you can see it, but that allows me to bring it into the rendering environment and actually have like a light source there that makes these really nice shadows using these shapes that are extruded through. But I'm kind of jumping ahead of myself. I'm going into what I want to talk about in my next video. So yeah, just a little sneak preview there. Yeah, so basically that's how you get started with that, with just using the line tool, a sketch constraint, to really get the bulk of this design done by simply taking advantage of your sketch constraint. All right, I hope you enjoyed this lesson. I think that it really demonstrates the power of sketch constraints and how A little knowledge can save you hours of frustration as you approach your designs. By taking advantage of sketch constraints, you can really simplify your design approach and avoid going down rabbit holes and dead ends, having to restart over and over again and trying to create a model. Another big advantage is that it also allows you to come back and make changes without destroying your model. I highly recommend checking out my sketch constraint cheat sheet. You can get it. I've left the link below. And if you found this video helpful, let me know by commenting below. All right, I'll see you in a few.